My name is Marco Pesce. I'm an application engineer at Leane International. What we see today is just a few info about our company, then a quick look at the pass-by-noise testing protocol, and then a more detailed insight into our solution we developed for customers of ours. And finally, some information about GarageLab, which is an important part of our solution. So about Leane International, our company is based in Parma since 1968. So we have over 40-year experience in the test and measurement market. We deal with automotive, avionics, industrial equipment, and power. And the company started with sales, but then we developed pre- and post-sales services, consulting, outsourcing, system integration capability, and full hardware and software development. And last but not least, we are partner of Dewesoft since the beginning. So we too are celebrating 25 years of being together with Dewesoft. It's a small company, family-owned, just about 30 people plus a couple of external. And we have an automotive division dealing with vehicle dynamics, performance and efficiency, fuel consumption, ADAS test. We deal mainly with full vehicle test, both on road, off-road, on proving ground, and some test benches also. We develop tailored solution as a system integrator. We provide also full support, training, and services, as I said. Our main partners in the automotive are, first of all, Dewesoft, and we work with AB Dynamics for steering robot and driving platform, mainly for the ADAS sector. Genesis for GNSS and IMU. Sensoric Solution, a new company dealing with optical sensor and a lot of, let's say, other solutions related to direct ground measurement of speed, sleep, forces, and so on. Motion Data for soft targets, mainly for ADAS testing, and Rototest for dyno bench. Our main customer are, let's say, the main car, motorbike, and truck makers, from Stellantis Group to Ferrari, Lamborghini, Porsche Engineering, Nardo Technical Center, Iveco, CNH, and many others. Tier 1 supplier, mainly tire manufacturers working in Italy, like Pirelli and Bridgestone, but also other suppliers like Brembo and others. Research center and defense industry, Leonardo Group, Iveco Defense, Augusta Westland. Let's go to pass-by-noise. Just a few words about the testing protocol and the regulation. Well, pass-by-noise is mandatory to get type approval for vehicle and tire also. Just to mention the main regulation we have in Europe, we have UNICE 117 dealing with tire noise emission, regulation number 51 dealing with motor vehicle emission, and regulation 40 dealing with motorcycle noise emission. The test procedure is barely simple at the first view, because the vehicle just drives through a measurement base at a target speed in a certain driving condition that could be in neutral or in full throttle, or according to the standard. And in this measurement base, we have two microphones that measure the noise. The test protocols differ in a few things, mainly the vehicle target speed, the driving condition that could be coasting or constant speed or wide open throttle, and in the data analysis and normalization of results. Going to our application, the use case that our customer had is Regulation 117, related to tire approval concerning the rolling noise. So the basic requirements is, as all the other standard, monitoring the environment condition, temperature, humidity, and so on, wind speed, wind direction. And the application in this case is for heavy commercial vehicles, and it's required to run several repetitions of the test in a range of speed around 70 kph, plus minus 10 kmph. And the driving condition is coasting with the engine off. And okay, so as in other procedure, we need to acquire left and right microphone with a weighting and certain characteristic of the, let's say, filtering and so on. And finally, it's required to have a fitting of the data according to the regulation in order to normalize the output at the nominal speed. Additional requirement of the customer is to correlate the noise to the vehicle position for R&D purposes and test at different sites without having an RTK, which is a feature required by the previous solution. And it's also an important part of the cost of the system, having RTK. And the whole test procedure should be controlled by an operator on board of the vehicle. And this is another difference compared to other solutions. And then, okay, store the background noise before each run directly into the test file, being able to execute the test in both directions seamlessly. So without having to tell the system, now I'm going forward, now I'm going backward. And automatic check of each test run immediately after the stop storing. And finally, automatic post-processing according to the regulation standard and fitting of the results and exporting to a template report. So our solution, the customer wanted to move to a Dewesoft system because he already had some hardware from Dewesoft. And to have it working, we did some development study, and we decided to integrate Dewesoft with putting on top of all the sequencer to automate the test workflow, and to add the analysis script in our tool GarageLab in order to provide immediate feedback after the test measurement, and batch data processing and custom report generation. Going into some detail, let's start from the configuration. Of course, we have a part of the vehicle and a part of the test instrument that is on the ground station. On the vehicle, we have a tablet PC, which is the main user interface for the test driver, a DS VGPS, 100 Hz, and its display, which is useful to have another comfortable device for the driver to monitor the exact speed of the vehicle. Additional sensor like a photocell, which is required to trigger the test, the start storing, an infrared temperature sensor, which is installed on the vehicle to monitor the asphalt temperature. And finally, a DS Wi-Fi 4 kit in order to communicate with the ground station. In the ground hardware station, we have another laptop PC running Dewesoft. We have a DV43 measuring data from a couple of grass microphones through the SI ACC module. We have a DGPS just for the purpose of synchronization, and another DS Wi-Fi 4, obviously, for communication with the vehicle, plus a vehicle weather station from Vaisala. And part of the kit also is a microphone calibrator and a couple of reflector strips, which are, let's say, fixed on the asphalt at a precise distance in order to trigger the measurement. On the software side, we have, on the vehicle, DewesoftX, a remote link with the net option, a Modbus client needed to acquire data from the infrared temperature sensor, and our pass-by-noise software based on GarageLab runtime. On the ground station, we have, again, of course, DewesoftX with the net option and sound level plugin and weather station plugin to get data from the Vaisala weather station. As an overall architecture, we have, on top of everything, the Dewesoft sequencer, which manages the workflow automation. So it manages DewesoftX concerning data acquisition, so the sequencer loads the proper setup, and then it interacts with Dewesoft through the different stages of the test procedure. And when the test data has been stored, it interacts with GarageLab, passing all the details in order that it's able to post-process the last stored data file, or at the end of the procedure, the whole batch of the test run. So basically, you have a menu in the setup, which is managed by the sequencer. And the menu allows, through just a few buttons, the driver to set some initialization parameters, then to inspect the live data, go to the measurement loop, and to the analysis. When he goes into the measurement loop, here he enters another, let's say, screen with some buttons to store background noise, to start the measurement. Measurements are stored in a data file, and automatically the post-processor provides the results of the measurement. We have a few, let's say, 3 core choices that we had to make when we developed the solution. So now we see just 3 short highlight on a few technical aspects. The first one is having to do without RTK. We choose to have. We needed to have anyway a precise positioning of the vehicle along the measurement base. So we decided to use some reflector strip and to trigger the storing based on this reflector, and integrating the vehicle speed in order to have the distance traveled, and then it's offset in order to have 0 distance corresponding to the microphone lines. And this addressed the customer requirement related to correlate the measurement, the noise, to the position in a precise way, even without RTK. This is an old-style solution having a photocell and reflector, but it is still widely used, and it's very precise and very easy to put in practice. So we have, as I said, a 100 Hz receiver. We did some tests in order to check that the accuracy of the calculated distance is right, is within specification. So we know we are around not centimeter level, but for sure in the 5 centimeter accuracy range. And so we are confident that we have a good correlation between the noise and the position of the truck along the track. So the start storing trigger is issued by the mark input of the Dewesoft GPS and corresponding on the reflector. And simply placing another reflector on the opposite side of the measurement base, we can trigger the acquisition in the opposite direction. And then with some mathematics, of course, we can detect the driving direction. The second highlight is about the automation workflow. We decide to stay on the sequencer for simplicity and to avoid to develop a, for sure, more time-consuming and more costly dedicated application using, for example, DCOM, as we do for other test cases. So we used the sequencer. We implemented a, let's say, easy and simple user interface using buttons, which are provided in Dewesoft setup as user input controls. And this is a nice feature we were able to exploit. And then as I said, with just some basic mathematics, we are able to implement detection of the driving direction. And so to recognize the driving direction and to swap the left and right microphone channels in order to have proper left and right recognition. So other details, of course, since the procedure had to be managed from on board the vehicle, we set the measurement unit on the vehicle as a net master. And so when the driver on the vehicle start the setup, the net protocol automatically load the measurement setup also on the ground station, on the net slave station, that can be left unattended. So the ground station measures data from the microphones at high speed, 50 kilosamples per second, and the weather station data. And it send the ground station then send data to the vehicle. This is another interesting feature because, and it is typical, and it's let's say available in Dewesoft. The fact that the microphone data from the ground station are sent to the vehicle already digitized, so needing no further calibration because other systems send analog data, and then there are other issues. Okay.
So from microphone 1 and 2, you have cables? Or?
We have cables going from the measurement base to the DV43, which is in the ground measurement station.
Yeah, so you need to have like a tunnel?
Yes, yeah.
Not only in reality, because this data acquisition system was designed to be used also in third-party proving grounds, so they have also the possibility to use external cables. We choose the eye-protected cables for the environment, for the scratching and so on. So there is no wear practically, but they can use also external cables up to 50 meters actually.
So you can drive over the cable?
No, there is the possibility to to pass the cable on the other side. There is a small tunnel between left and right only in this case, but with the rest of the cabling can be outside. Yeah, the problem of passing on the cable is multiple. You may have broken cables, but we have also noise, additional noise, and immediately close to the microphones that is not allowed, of course. So at least the crossing between left and right has to be done underneath.
Yeah,
Absolutely.
okay. So you can do the test 2 times with just one microphone and move it?
It is possible, but it takes 2 times, and in homologation test is not accepted because you need to have the measurement of the background noise and also of the noise during the test together. So for research, for their own measurement, it's okay, but the homologator does not allow to do that. And this is the other problem that, come here. This is the other problem. This is the other problem that came from the homologation guys. Once they decided to buy a new system, they had the old one was from Brunel before HBK, and it used analog telemetry to send the data. And the homologation guys does not accept very with happiness, let me say. They have to make some discussion every time because the transmission condition in analog could change during the test. And so they say, okay, if you want to act in this way, you have to make the calibration many times during the day. On this way, we transmit the data that is already calculated at first, And then second thing, we also store the raw data, the real data, on the local DV43 on the ground station. So we transmit only the important values, but we have everything. So on this way, they can prove what they did. They can make some specific analysis in case they do not pass the test. They can make, I don't know, an FFT analysis or sound analysis in any case to understand which are the frequency that create the problem. And also there was another problem that merging Brulin here into HBK, they were not anymore allowed to find other external vendors. We as Leane, we can work with Dewesoft, but also we are free to find solutions that can really fit the application. In this case, all the additional things that we were requested from our customer were on that direction. The additional, I don't know, measurement of the temperature during the travel instead of measuring directly on the place of the microphone that is requested by the regulation. The small adjustments that we were able to do in an easy way for the customer. So this was most important for them.
Yes.
Okay.
Then this is about some technical issue about measurement setup. Going to the workflow automation, as I said, we manage it using the sequencer. And a nice feature of Dewesoft, which is providing buttons. So we adjusted a few displays in the measurement setup with proper buttons. And the sequencer detects the pressure of each button and acts accordingly. And the main function implemented to keep things very, very easy for the test driver is an initialization of the test session. So typically they have to input some ID of the tire specification and some ID of something else. And then we define also the orientation of the track in order to recognize the driving direction, and the vehicle length in order to trigger the stop storing when the vehicle is completely outside of the measurement base. And then there is another button to check live data, which is important when you are on the track to check, for example, that the Wi-Fi connection is working, because Wi-Fi is one of the critical points, especially when you are at the start of the test lane. You are a bit far from the ground station, or when the Wi-Fi antenna is on the opposite side, so the vehicle is in the middle between the antenna and the ground station. There are some, let's say, not clear view. So checking the live data is important in order to see that everything is working. And finally, the most important is the pass-by noise measurement. Here, this is implemented in a kind of a loop, so the driver stays in the measurement displays until he decides to exit. And when he is in the measurement display, he has to repeat a few operations, that is, checking the background noise and press a button to store the background noise in the file. This also arms the trigger. So the trigger is not armed if he didn't store the background noise in advance. This is a customer requirement. No problem, we can do that. Okay. Then there is the test itself. So he starts driving at the desired speed through the measurement base. When the reflector is crossed, the trigger starts. The acquisition lasts just, let's say, no longer than a couple of seconds, but usually less than a couple of seconds. So everything is very quick. At the end of the acquisition, the post-processing is started automatically. And so the driver loops through this process until it's necessary. And at any time, if you want to check the results, you can go back, move to the analysis function, and check any individual test run, or try a batch analysis of all the test runs. And here comes the last technical highlight, that is integration of our GarageLab Python script environment. So it's not pure Python, but because, let's say, one of our developers had the idea to remove the complexity of, for the test engineer related to having to write specific code for having a nice graph, for having a table, for reading files, and so on. But we will see this later. So basically, this is why we have GarageLab and not pure Python. And at this stage, we use the nice function, again, of the sequencer, which is an open file block. From the open file block, we can send a call, calling an external application. So we call the GarageLab runtime, telling it which is the script to run, and which is also the file to analyze. So we can send multiple parameters that can be managed. And so we have this call at several different points. As I said, the first point is immediately at the end of each test file storage. So automatically, when there is the stop storing trigger, the GarageLab application is run, and the last stored data file is shown. And the other entry point is from the analysis button. When the driver wants to make an analyze, he goes to the analyze menu and choose whichever file he wants to analyze. But now we can see it from a video. It's easier. It's just, sorry, of course. It's not here. Okay, this is the, sorry, we missed the beginning. Okay, this is the main menu. We start with the initialization. Here we can enter some data. By the way, this is a kind of simulation environment we used in the development phase, using Polygon and simulated channels and the vehicle simulation plugin. We were able to test everything before going to the proving ground. So here we can check live the bearing of the track. And I just go back for a second. So here we can drive along the track. And here we can check the heading from the GPS. And in this user input control, we can input the actual direction of the track. So it's, okay, let's say about 102 degrees. Then we can go back. We check live data. So here we have, of course, these are simulated values, but we can go forward and backward. So here we see direction is 1, but it gets 0 when we are backward, and we see here in this widget that we are going reverse. Everything nice. Okay, we go to the pass-by measurement. And here we are at the beginning of the track. We press the background noise button, and the trigger is armed, and the background noise value is stored there, 35. Of course, it's very, very, very low in this case, but it's simulated. So we go through the measurement base, start storing. Here we have noise measurement versus traveled distance. And here we have the post-processor. We have some green light, some yellow light that is a warning. We can anyway accept the test or delay the test. And then we are ready again for another run. Of course, on the proving ground, you need more time to go back and forth. Yes?
When you reject the test, does it delete the stored data immediately? Or
Yes, it deletes the stored data. But of course, it's possible also to put it apart maybe or do whatsoever. This is done by the Python script. And it also renamed the test according to the traveling speed. So when it comes to having a post-processing, the test engineer can see exactly what was the speed. But again, this is a custom feature which could be done also in a different way, of course. So, okay, it's repeated a number of times. We do not do all the run. Usually 16 runs are required in order to have some repetition and the possibility eventually to choose the best one for the final report. And okay, here we come now. Finally, we go to the analysis. And global is to have the global analysis of all the tests run in that precise folder. So here we see some widget where we have a table with all the tests run listed. Here we see the details of the highlighted one. In this case, it's the first one. We have some OK or KO indicators there. And we have the possibility to include or exclude some runs and see immediately the results on the regression characteristics. And finally, that can go to the report when
who clicks the background noise? Is it inside the vehicle, you say?
Yes, it's inside the vehicle.
Yeah, okay. So there's no one needed outside?
Yes, exactly.
Yeah.
That was one of the requirements. Of course, in many times there is a technician also in the ground station, because it can be, let's say, convenient in order to fix something or to adjust something if needed. But in theory, the whole test is managed from on board the vehicle. Okay. So let's go back here. And now a quick introduction to GarageLab, which is a nice part of the solution. And so what it is, it's a tool designed to write script in an easy way for test engineer. So they are not a programmer. A test engineer is not a programmer, but he knows what he needs, and probably he also knows how to implement calculation, because every engineer now has some coding skill. And Python is the most widely used scripting language. So it's very, very common. It has a lot of libraries and extensions and so on. And the other feature of GarageLab that it has embedded support libraries that make easier programming for test engineer. For example, making plot and reading data file and so on. And where does it fit? It fits as in this example where it's not worth and maybe there is no time to develop a classical application in a classical development language that requires detailed specification, requires a professional software developer to work on it, requires compiling, then testing, debugging, compiling again, and it's quite complex. It's more easy sometimes to do this by a technician that exactly has in his head what he needs, and he has some coding skill, and he can directly couple, for example, Dewesoft with an analysis script that does exactly what he needs. So just to be clear, so on one hand, we had application that we can solve just with pure Dewesoft. So we have mathematics plugins, C++ extensions that we love very much, the sequencer, but also export template. But sometimes this is not enough. Especially it's not enough when you need to work on multiple files and you need some more details on spatial post-processing and so on. On the other hand, you have the classical external application that, like our VTS suite, for example, that interact with Dewesoft via DCOM, and then it manages Dewesoft for all its needed about data acquisition, and then in the application itself there are other workflows and post-processing or whatever is needed. This is a complex and rather costly and time-consuming task. So we needed something in the middle, and this is what GarageLab does. So it's an environment for easy coding, providing the key is here, support library for low-level tasks, and the possibility to implement a nice dashboard with multiple tabs, widgets, map widgets, plots, tables, and so on, with just a few lines of code. So any test engineer is able to do that, and is able to do that in a very short time. And the added value, so that the test engineer may focus on what he really needs, that is implementing technical calculation and getting the desired output. Okay. Some application we did in this way, for example, is one of the first was motorbike performance analysis. In this case, we did use Dewesoft. The customer had a simple GNSS system with IMU storing data in NMEA format. So he just needed to read the NMEA file and post-process that, and extract KPI for acceleration, braking, fuel consumption, and so on. And this is where, for the first time, we applied this solution in 2020 or 2021. Then some integration with Dewesoft began. And one of these is, for example, end-of-line brake tests for industrial vehicles, where the customer needs to test every vehicle, for example, truck lift or something like that. And the test procedure is very simple, but as you see, it can be done in a very similar way to what we did for pass-by noise. I mean, let's say, input some identification data of the test vehicle and something like that, check the values, make the brake test, get the result with pass-fail results, and eventually also storing the data on a TXT file to have everything logged and ready for preparing a report. Then another nice application, a bit more, let's say, complicated, because then when you do real test, the difficult comes out from details and from practical things. This is on-field traction test. In order to characterize the traction behavior of the tires. So definitely we had a couple of tractors. The tire under test is fitted on the first tractor. The second tractor acts as a brake, and the brake force is increased time by time. We are on a field, we do several, let's say, pieces of acquisition back and forth. Every time the tractor drive a bit aside in order not to drive where it already passed in the previous run, to have always, let's say, fresh soil in order to keep always more or less the same testing condition. And also in this case, at the end, we had to customize some post-processing for each piece of acquisition where the brake force had a bit increased, and to calculate the tire slip and the tire force, and to fit the data, and to extract some KPI related to the tire slip characteristics. And finally, maybe the more complex application we did, it's a suite for a calibration lab. It started with let's say, almost as a joke for a single device, for example, calibrating a measurement steering wheel characteristic, steering wheel angle characteristic and torque characteristics. And then it increased because the customer wanted to say, okay, beside the measurement steering wheel, we can calibrate pressure transducer, and then load cell, and then this and this and this. And so we started from the automation concept that is always the same, Dewesoft sequencer. In this case, using the test cases, which is a nice option of the test of the Dewesoft sequencer, which allows also to add parameters. So every test case can be parameterized according to the needs. And in test cases, you can really list a set of steps, and you have to go through all the steps in order to accomplish the test. So test automation in Dewesoft sequencer, store data file, and then the post-processing done in GarageLab. But in this case, we had, after the initial, just one kind of sensor, we had to manage a database of different kind of sensor, and a database of the calibration equipment, each with its, let's say, calibration certificate, validity, and so on. And so definitely the post-processing is just the last thing and the easiest, maybe. So we grab the measurement files, calculate regressions and sensitivity, uncertainty, and so on, and put everything on a PDF report according to the customer's specification. Last thing, this is up to now. The next step is developing a V2 version of GarageLab, which will be cross-platform. It's intended to work on Windows, iOS, and Linux. It will have OpenDAC integration. We are working on it right in this period. And more live data processing. Live data is already available in the current version, but definitely has been used not so much. We are planning to use it a lot more in the future, also with integration of OpenDAC. So, thank you.